Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're going to be doing a little project out here in the shop. I'm going to be cutting some bevel gears, and I'm going to be honest with you guys. When I realized a month or two ago that I had a need to cut some bevel gears to fix a broken gear on a metal planer that I'm restoring, I started doing some research and looking into what all was involved in cutting bevel gears. I've never done it before. I've cut tons of spur gears, just regular gears with straight teeth across them, using the milling machine with an involute cutter and a dividing head. I'm very proficient at that, but I had never attempted to do a bevel gear before. And I started doing some research and delving into it and realized real quickly, hey, there's a lot to this. There's a whole lot to it. Not impossible by any means, but there is a lot to it. And I want to go over just a few of the basics and things you need to know before you get ready to start cutting bevel gears, and then we're going to go do it. But I'm going to start off by just saying that cutting bevel gears on a milling machine with an involute cutter is really not the ideal way of cutting a bevel gear. The best way to do it is to use dedicated gear cutting machinery, such as a gear hob or a gear shaper. I think a gear shaper is probably the best way to do it because when you use those tools, you develop a 100% true involute cut in these gear teeth. It's true really for any gear, including spur gears, but I think it's even more so true with the bevel gears. But with that said, it still can be done on a regular milling machine, and that is what we're going to be doing today because that is the machine that I have. I don't have a gear cutting machine that I can go use without sending it out and having someone else do it. Let me zoom you in here. I'm going to go over a few little things you need to know before you start cutting bevel gears, and then we'll go get it done. So to start off with, do your homework. And I have two really good books here. The first one is Machinery's Handbook. If you got anybody that has a machine shop, even a hobby machine shop, you need to get a copy of Machinery's Handbook. They're easy to find. You can buy them on eBay. You can buy them brand new. But these things are full of information for just about anything that you do in a machine shop. And there's a whole chapter in this book on bevel gears, and all the math, all the formulas, everything you need to calculate, it will tell you how to do it in here. Another good book that I've got is this one here, a treatise on milling machines, or milling and milling machines. This is by the Cincinnati Milling Machine Company. It also has a very good chapter in it on cutting the bevel gears on a horizontal milling machine, which is exactly what we're going to be doing. So I would definitely, by all means, you've got to have this book. Again, if you got a machine shop, you got to have this book. This one here, big help. I will say that some of the formulas between the two books aren't exactly the same. They kind of come up with the same answers or something real close. I would pick one or the other and just make sure you're running all your math using, not be mixing the formulas back and forth. Either one of them will get you to the same place. Now, as far as the math is concerned, I created a spreadsheet, and I actually use that to do a lot of my math for me rather than trying to do it on a calculator. And guys, I know I'm gonna get somebody to ask, hey, can you send me your spreadsheet as a starting point? And I'll be honest with you guys, this spreadsheet is not really something that I'm willing to send out, mainly because there's a lot of gotchas in it. It's not just where you put some numbers in and it calculates everything. There is some numbers that have to come out of tables in these books, and I don't have all that programmed into the spreadsheet to automatically calculate it. And I kind of know what has to be done, but it'd be difficult for me to tell someone how to do that and come up with all the right numbers. But I've calculated the main things I need to know. So as far as, really the important things you really need to know, I need to know the angle to cut my face. So the face angle calculates here, in this case it was 40.684 degrees. There's really three different angles you got to know in here. There's the face angle. There is the pitch angle, which is kind of where the center of that is. Really, I don't guess I need to know that, but that's really kind of the angle that the gear is calculated on. And then there's the cutting angle. There's another angle that's down in the bottom of that, and that's the angle that the cutter's going to go through here. Because with a bevel gear, the tooth is bigger in the back than it is the front. If you look here, see the front, see the back, That's because it's running, you got a change in angles. The angle that the face and the angle in the bottom are different, so it's cutting more out of the back than it is the front. Another thing that you need to know is the outside diameter of the gear. We calculated that right here, outside diameter. In this case, it was 1.633 inches based on all the measurements that I have here. And another very important one here is the hole depth of the cutting depth, so off of the big end. So you touch your cutter off up here and it tells you how far you need to feed down to cut that out. And there's lots of other things in here, and some of these you have to calculate one thing to get something else. But all the math is right here. You also have to know your offset distance and roll angles. We're going to talk about that in just a minute. I've got you zoomed in here on just a diagram showing a pair of bevel gears. And again, I just wanted to make sure we understand a few things. So the outside diameter is going to be from the tip to the tip out there. And again, we've got some different angles here going on. So that pitch angle is kind of this line in between. That is kind of where the cutter really kind of starts bending over in that arc. It's kind of center of that arc. But again, you've got an angle of the face, and then there's also a cutting angle, which is different, because if you look, that's not parallel lines. Those lines kind of come in. It's bigger on the outside than it is on the inside. Another thing I want to just real quickly mention is the actual involute cutter that you use to cut bevel gears. So there's a standard set of involute cutters that are used for making spur gears. I've got a pretty good collection of them. And for comparison, this one here happens to be a 6-pitch number 4. So if you know anything about cutting gears, you have different pitches, and there's 8 different cutters within a pitch depending on the number of teeth as to which one you use. So this is a 6-pitch number 4 for regular spur gears. This is a bevel gear involute cutter. It is also a 6-pitch number 4. And I want you to look at the difference in the tooth down here. Can you see that? The bevel gear involute cutter is thinner than a regular spur gear cutter, and that is because that front of the small end is narrower, and as it gets to the back, it widens out down in that bottom, and it really makes it difficult to use a regular gear cutter to do this. It can be done. If you look in the machinery's handbook, it actually talks about you actually have to use a different pitch cutter, I believe it is. I haven't studied it real hard because I happen to have a bevel gear cutter. But you just can't go use a regular cutter. Another thing you have to look at is on the number of teeth. You have to mathematically calculate the number of teeth. So another thing you have to watch out for is on your number of teeth. Like I said, you pick the involute cutter based on the number of teeth that you have. With a regular spur gear, we're doing 18 teeth. But there's a formula. You have to convert that for bevel gears, and you actually select a cutter as if you were picking one for 22 teeth instead of 18 teeth. So again, do your homework. That's the main thing I'm trying to tell you here. All this information is in Machinery's handbook. But note too that I have found that finding these bevel gear involute cutters is extremely difficult, at least to find new ones. You can find old ones, and I'm fortunate. I've got a pretty good set of these through a lot of my pitches, but I don't have all of them. But I had fortunately the one I needed for this particular job. But regular cutter is different for a bevel gear. In preparation of cutting the gear I'm going to cut today, instead of just going and doing my first attempt out of my metal blank that I cut, I decided I was going to do a practice run and just make sure I had everything down. So I actually just turned the gear. This is a piece of plastic is what it is. It's just some Delrin, I think is what it is. And that's a piece of scrap I had laying around the shop. I cut all the tapers and all the angles, face angles and all that on it, and went over and just quickly did it just to make sure I had my process down. And it came out perfect. I probably would have been fine had I just gone straight to the metal gear, but I wanted to test everything. But here's something else you got to really look at, is that you see how this gear gets thinner down here in the bottom? Well, when you just run it through straight, what it ends up happening is you don't get it thin enough down in the bottom. So you have to make 3 passes on the milling machine to get an approximate gear tooth. And the first one is just a regular one straight through. The second one, you actually move the part towards you and then turn it back just a little bit. And you can almost see it on here, but you've actually got on each side, there's like two angles. So it comes in and there's another one that comes in at a little bit different angle. It makes it a little bit wider down here in the bottom or thinner on the top and on the small end. So you have to actually go around in 3 different times. That's another thing you have to calculate is your offset distance. So how far do I have to move the part either to me or away from me? And then how far do I have to rotate the part? And again, I did the math for the gear that I'm cutting, and those numbers are here. So I had to do 15 thousandths of an offset and a roll angle of 1.317 degrees. And basically, I just used my index plate. I figured up how much one hole on my index plate was. I had to basically go 4 holes either side of that first cut to get something really close to that degree. It wasn't exact, but it was pretty close. And when you cut bevel gears on a horizontal milling machine, one of the things that you often have to do is you have to go in here after it's all said and done with a file and kind of blend in that little center section where those 2 angles come together. And here's a diagram in one of my books, and you can kind of see what we're talking about. So the dashed line here on the outside, that was the original cut that we had, and you have to go in here and kind of take that dashed area out. And that's what that offset and roll does, is when you do that, it's just kind of taking a little bit out. So again, when you end up, you have really 2 angles across the top of this. It's not a smooth arc like it really should be, which is what you would get if you were doing this on a gear shaper. But we can get something really close to that profile over here. Gears cut, bevel gears cut on the horizontal milling machine work okay in slow turning applications. When you get into high speed applications, that's when you can really run into some problems with these angles not being just right. With this particular gear that I'm cutting, it's basically going to be an elevation screw on a machine. It's going to be turned by hand, probably very slow RPMs, probably 3 or 4 rotations per minute is all it's going to ever turn, and not very many revolutions at any given time. So I think that this is going to work out just fine. So guys, that was a really quick and really pretty tame introduction to some of the technology and science behind a bevel gear. And I will be the first one to tell you I am far from being an expert on this, but I have done a considerable amount of studying on it the last couple of weeks, getting ready for this job, and I have a good understanding of it. I'm not sure how well I conveyed that, but I'm going to just be honest. There's a lot to this. It's something you can do, but do your homework first. Study it, make sure you understand what's going on, and you should be able to produce a successful bevel gear. Let's go over to the mill machine now. We're going to get set up and we're going to do some cutting. I'm over on the milling machine now, and I've got my dividing head set up on the milling machine. This happens to be a Kearney Trekker Model H dividing head. It's a 40-to-1 ratio. So when you turn the handle on the front, 40 revolutions of this handle here will result in 1 revolution of the chuck up here on the front. And you have different index plates. These plates have different sets of numbers of holes in them, and there's charts, and mathematically you can calculate and figure out which plate you need to get the number of divisions. So our gear has 18 teeth. So to get to 18 teeth, I'm using, in this case, a 27 hole pattern. So I'm in one of these circles of holes that has 27 holes around there, and to get that division that I need, 18 divisions, you go two full revolutions plus 6 holes, and there's a little sector in here. You put that over there on this hole, and then you just pull it around, and it will tell you right when you get to the 6th hole. You can adjust that little scepter in there to help you find that. So I've got all that set up already. And then the other thing I had to do, because we're doing an angle on our cutter, I've got this set, and my cutting angle is 32.459 degrees. Well, now my scale in here is just it's incremented in 1 degrees. So I just kind of eyeballed it, and it's about 32.5 degrees is what I'm at. It's probably not the exact cutting angle, but it's going to be close enough. And there are ways you can set this thing up and get it exactly right, but guys, I'm gonna be honest with you, we're splitting hairs when you get down to, you know, 1/10 of a degree over such a small area. It's just not gonna matter. So anyway, I tilted it back. I read my angle right there. Everything's tightened down, and we are ready to put our part in here. In this case, it just goes into the chuck, and let me tighten that up. Need to make a proper chuck key for this chuck, but that 1/4" drive fits it pretty close. All right, that is firmly in place. And again, the angle that I'm doing is my cutting angle, or the angle that's in the bottom of this gear. If you look, the angle on the top is not flat. That's because it is two different angles. The face angle is 40.68 degrees, and the cutting angle is 32.45 degrees. So again, as it goes through, it's going to be making a heavier cut as it gets to the back. It's cutting more material out of the back because that top is at an angle. As you go through there, it's getting thicker and thicker as you go through. We are set up here. I've already got my cutter set up on the center of this, and we're ready, I think, to start making some cuts. So let's get in here. First thing we need to do is we're going to touch the cutter off on the large end, and I've mathematically calculated the cutting depth, which is 180 thousandths. So after we touch off there, we will raise the table up 180 thousandths, and then we should have our full cutting depth. And I think I can cut this all in one pass without any problems. We'll give it a try. If we have to, we'll back off and do it in 2 passes, but I think if I slow my feed rate down, we'll be fine. All right, I've got my cutter running right over the center of this thing at the highest point there. And what I'm going to do is just raise this up until I just touch off right there. I'm actually touched off. That should give me a starting point on my depth. I'm going to move out now. I've got a dial indicator set on the top of the machine going down to the dividing head, and we're just going to raise the table up 180 thousandths of an inch. So I'm going to release my lock. There's a little bit of wear in this machine, so I have to be careful when I lock it. That's 100, 50, 60, 70, 80 right there. And there we go, right there, and my table is locked in place. Zoom 33. All right, I think we're ready to make our first cut here. I've got my RPM of my cutter set up at about 150 RPM. I think it's 153. And I've got my feed rate set real slow to start with. According to the calculations, I can go like up to 15, 20 inches per minute, but I don't know that I'm brave enough to do that. So anyway, I got it set on something real slow right now. We'll just feed it in there. I think it's 1 inch per minute. And we'll see how this goes and then speed it up if we feel like it's cutting good. All right, I can hear it cutting pretty good now. And of course, as it gets into that cut, it's going to be taking a deeper cut as we get toward the back. Since we're cutting the full depth all in one pass, I'm slowing my feed rate down to kind of compensate for that. I always get comments from folks about my arbor's not running true or my cutter's not running true. And guys, that's just the reality of working on a horizontal milling machine, particularly when you got an old one that's wore out like this one is. It tends to have a little bit of a wobble in it, and it cuts more on a couple of teeth in there. But slow down your feed rate and everything will be fine. You'll kind of average it out over there. It's going nice and slow through there. So that looks like it's cutting just fine. I'll probably, on the next one, we're gonna speed our feed up there a little bit because I think we can go a little bit faster. Let's let it get all the way through cutting though. All right, number one, we will one turn, 2 turns, and 6 teeth right there. Should be ready for our second cut. And I'm going to go up to about 1.75 inches per minute on that. So let's feed that in there now. So the first pass again was 1 inch per minute was my feed rate. I'm up at 1.75 inches per minute. So we're feeding a good bit faster this time. All right, come out. Unlock the dividing head. And again, 1 turn, 2 turn, and 6 teeth right there. We'll lock our dividing head and we'll feed in again. All right, I sped my feed rate up another notch, so we're at 2 1/8 inches per minute now on the feed rate. It'd be a lot better if it was cutting on all the teeth, but it's pretty much just cutting on a couple of the teeth in there. So I'm probably not gonna speed it up much more than this right here. If we, like I said, if we were cutting on all the teeth, I think we could go a good bit faster. All right, we'll turn our head again. Make another cut. Just kind of rinse and repeat after this. You just keep doing this until you get all the way around. Last one here on the first operation. Split the difference. Love to see them when they line up perfect like that. So first thing I want to do is I want to move the table. I'm going to come toward me, and my offset distance is 15 thousandths. So I'm going to unlock my table here, and we are going to bring this toward me. Making sure we're nice and free, make sure I got a good zero there. And that's 10, 15 thou right there. We'll lock our table back in place. So if I was to come in here right now and do this, it would just come right down this back tooth here, and it would more or less just go straight across. But what I'm really wanting to do is kind of trim up this front edge. Again, it's going to be angled, and to do that I need to roll it over now. What was it, 1.3 degrees, and that equals 4 holes in my dividing head. I'm going to roll it over 4 holes. We're just going to go in here and manually count them. That's 1, 2, 3, 4. I move my scepter over, and we'll just go around again, starting in this hole, go all the way around and do each one of them. And then we'll have to go back and roll it the other direction. All right, here we go. And we're just going to be cutting off this little corner right over here, about halfway up. It's going to be a light cut. I can barely hear it cutting. It's not taking much off, it's just fuzzing it, but it's getting that geometry of that gear tooth just right. Put a mark on here so I know which one I started on. We'll go all the way around and cut each one of them. And like I said, when we get through, we'll come back and we'll cut the other side. We'll offset and roll it in the other direction. The last cut here. And I like to go back to my starting tooth. And now we're going to do our offsets again. I've set my indicator back to the 15 thousandths because we need to go 15 thousandths in the other direction. So we'll go back to 0 and count back out 15. So let's bring our table in. We're back to 0, 10, and 15. And now I need to go back the 4 holes and then 4 more. So we go 1, 2, 3, 4. That's back to where we started from. 1, 2, 3, 4. I'm gonna move my scepter down there to that one. I actually want to go past it, and because I'm turning in this direction, I want to come back to it. That just takes out any backlash. We will start on that hole now and go around and do everything again. One more pass, and we should have this thing trimmed up. And away we go. I'm not going to make you guys watch this whole thing. We'll bring you back at the end. Well, now for the moment of truth. I believe it's going to work. I need to get that shaft in there and make sure my alignment and everything is just right, but that looks and feels good. I think it's a success. Well, there we go, guys. My first bevel gear. I hope I did it right. We will know for sure when I get it installed back on the machine. I can really test it out, but it appears that I got a good part here, at least based on just meshing it up on that other gear. So I think it's going to be fine for what it's going to be used for. And hopefully coming up soon in another video, we will get this installed back on the metal planer and really make sure everything's exactly like it needs to be. And with that, guys, that is going to be a wrap. I hope you enjoyed something. Hope you learned something along the way. I sure did. Like I said, I had to do a lot of studying on this, and I will again tell you guys up front, I'm no expert, just figuring this stuff out as I go, but sharing what I have learned so far. And I'm sure I've still got more to learn on this, and as more we do, the better we'll get. But one successful part at a time, that's what we do. Guys, that's going to be a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already, and thumbs up are appreciated, as are those comments, and we will catch you on the next video.